Hi guys, I'm going to be going over 13.1, but there are 3 things that I want to do with this task. Number 1, I want to take it back to partial quotients. Hopefully you remember some of this from 5th grade or lower. If not, it's okay, and I can provide an ed puzzle and plus this example in the video. Second, I want to connect partial quotients from whole numbers in the past to this number 1, 5 and 400ths divided by 7. So we have division involving a decimal and a whole number. Third thing that I want to do is look at number 2, but not go over it and give you answers, but to discuss an old pattern that hopefully you have come across already. And if not, now you'll have it and you can use it both now in this unit and in your work with the percents in the Unit 3 Blue Book. Okay, so let's get started. All 3 of those things are going to happen here. Okay, so first thing is first. Let's take it back and work on a partial quotient strategy for division instead of long division. The 2 are very, very similar. However, if you do partial quotients, you have a bit more freedom in what you can choose while you're dividing. If you're a bit restricted in long division. So let's look at how it's done with partial quotients. In the past, partial quotients, most likely, you have been taught to extend the right line and write the partial quotients on the side. However, what I noticed in the purple book, Unit 5, instead of keeping them on the right, they extend them upward above the division bar, and I'll show you what I mean right now. So we can do a couple of things, and actually I might be extra here and show you a side-by-side comparison about how you have choice. I can start this problem by saying if I have 4 100ths, I have 400, and that only took away the 400 out of the 983, so I'm still left with the 583 to divide. But I didn't have to start like that. I can also start a partial quotient by saying if I have 4 sets of 200, 200, 400, 600, 800, then I'm even closer to the 983. So you see how 2 people could be using partial quotients and they're still ultimately going to get the right answer, but their partial quotients actually look a little different, right? So that's a possibility. Now, on the left here, I can continue and I can say, I can do another set of 4 100ths. But maybe I notice something else. Who knows? But let's do that. Let's do another set of 4 100ths. 100, 200, 300, 400. And that is going to leave me with 183 left. And now you see, this is what I was talking about. How in your purple book, the partial quotients are going upward instead of on the right. I think they did that on purpose because this book is about decimals and we need them to line up. So if they connect your partial quotients vertically going up to what you're used to, then they're hoping that when you do partial quotients with decimals, that it'll help you keep that decimal in the right spot. So let's continue, because the whole point of this is to finish the division. Okay, now the one that I have left is 183. Well, you've got options here, but I know that 4 sets of 25 are going to get me 100. Right? Because if you think about your quarters, if you have 5 quarters and they're each worth 25 cents, you're going to have 100 cents, which is $1. So 4 sets of 25, and I'm going to have 100. What's left? 83 is left. Okay, well, that's not too bad because 83 is very close to 80. And if I count by 20s, 20, 40, 60, 80, 4 of them will be 80. That only leaves me with 3 left over. Now, obviously, 4 can't go into 3. But. 4 cannot go into 3. So this is literally 3 divided by 4, correct? So I can write that as 3 divided by 4. And you guys know what 3/4 is worth. 3/4 is worth 75 hundredths. I'll connect it to money again. Remember, 4 quarters makes $1. That's each quarter is 25 cents. If I have only 3 of them, I have 75 cents. Okay, now why this is important is because that's the leftover. The leftover is the 75 cents, which means I have to add all of these together. 20, 25, 100, 100, and the 75 cents. If I add all of those up, I am going to get the answer, the quotient. So let's do it. I'm going to start at the bottom. 100 and 100 is 200. I'm going to start here, 25 and 20. So 20 and 20 is 40. And the 5 has to come along. And then let's not forget about our 75 cents over here. So notice that these are whole numbers. And if I want to add my 75 cents to the mix, I am going to have 75 hundredths, 5 ones, 4 tens, 2 hundredths. So the moral of the story here is that 983 divided by 4 is going to yield 245 and 75 hundredths. Now, how do you check that? You can take out the calculator now and check your work, and you can plug in 245 and 75 hundredths, multiply it by 4, and you should get 983. So now that's partial quotients, and I would have gotten the same answer on this side, even though I started differently. Remember, there's freedom here, because now look what happens. What's 983 take away the 800? I actually skipped a step, didn't I? Because that was over here. The closer you can get to this, the less partial quotients you'll have. That's all. But maybe I didn't recognize that 4 sets of 200 is 800, and I could do that easily, right? It's okay to break it up. Okay, so that's the blast from the past. Now we need to connect it to the purple book, which is all about work with decimals. And you got to remember that decimals are the values of fractions. They're pieces. So don't be intimidated by them. They're still your numbers that you're familiar with. They're just pieces of numbers. Or pieces of something. Okay. Division is still the same, even with the pieces. You're making groups, equal groups. Okay, guys, I'm going to show you 13.1 again, the whole reason why we're doing this. 5 and 4 hundredths divided by 7. So we're on step 2 now. Okay. 5.04 divided by 7. And there's a decimal here, so I'm going to put it here so that I don't lose track. Okay? Okay, now, we know that 7 does not go into 5. Not completely, right? It would be something like this, 5/7, and that is not a whole. That is less than a whole. Because in order for it to be a whole, it has to have 7 out of 7. Okay? Anything less, and it's less than 1, it's a piece, right? Anything more, and it's going to be more than a whole. I hope you remember that. Okay? Okay. All right, now let's talk about the division part of it. 7's not going to go into 5, so I'm not going to have any wholes. I'm going to have a piece, something less than a whole. So 7 can go into 50, though, and it looks like a 50, but it's not a 50, right? Because under the bar, it's actually 5 and 4 hundredths. But I know okay, that if I take, when you think about whole numbers, 7 times 7 is 49, right? So that should mean that if I were to have 7 sets of 7/10, this is 7/10 up here. I was going to highlight it, but I don't want to because it's going to, if I erase it, I'll erase the whole thing. 1, 2, 3, 4, 5, 6, 7. If I were to have 7 sets of 7/10, this would be 4 and 9/10. How do you know? Just keep adding. What's 2 of them? 70 cents and 70 cents. Think about it. 70 cents and 70 cents. I'm thinking about money again because it helps me a lot. You don't have to think of it like money because this is 7/10. But if it was money, 70 cents and 70 cents, if that was in front of you, let's pretend they're dimes. I have 7 dimes on the left, 7 dimes on the right. I can move 3 of the dimes over and I would have $1. But then what's left on the right? It's $1.40, right? So that's the same thing as 1 4/10. It's just not money, it's a regular value. And that happens how many times? It's going to happen 3 times, and then I have this guy left over. All right, well, let's do this. 1, 2, 3. There's $3. So we could add up partially, right? 40 cents is 80 cents, and then another 40 cents would be $1.20. So far, before I added this last one, I have 4, if it was money, $4.20. But now I'm going to add that 70 and ta-da, 4 and 9/10, just like we said over here in our partial quotient. Now I'm going to erase that because that's not what we're going to end up adding at the end. What we're going to end up adding at the end is this guy over here, just like we did in the last one. Okay, what's left over? If you had $5.04 in your pocket. Okay, this is not money, but let's pretend. If you have $5.04 in your pocket, but you took away $4.90 because you purchased something, what would be left in your pocket? You'd only have 14 cents left over, right? 10 cents to make $5 and then 4 pennies after. All in all, it's just 14 cents. So now we're asking about how many 7s can go into 14 cents. Well, that sounds silly, doesn't it? Not even 1 can go into 14 cents. But if we're using partial quotients, we can talk about what will. And I'm going to use what we just did again, because I think it will help. Okay, there is something that I need 7 sets of, and that's going to equal 14 hundredths. Well, I know 7 times 2 is 14, right? If we're talking whole numbers. So let's do it with pieces. Let's test it. Let's see what happens if I have 7 sets, I can talk, of 200ths. 1, 2, 3, 4, 5, 6, 7. Just like you put an extra one. Let's get rid of that. That will definitely mess us up. 1, 2, 3, 4, 5, 6, 7. Okay, guys, let's add it up. 2, 4, 6, 8, 10, 12, 14. Well, what do you know? 14. And there's my decimal. Think of it like pennies. I have 2 pennies. And if right, this would be 4 pennies. Another 4 pennies. Another 4 pennies. 4, 8, 12 pennies. And then 2 more. So 14 cents. Okay, guys. We made sure that if I had 7 sets of 2 100ths, it would be the 14 hundredths, which means we have nothing left over, which is nice. This means that these are the only two that we have to add. So let's do it. 0.02 plus 0.70. And this is it. Now, pull out the calculator and let's test it. Let's test it. Let's make sure that we did our partial quotients correctly with the decimals. If you plug in 0.72, 72 hundredths, and you multiply it by 7, you should get 5 4/100ths. And if you don't, let me know, because something went wrong, either with my work or something that you came across. All right, guys, this means that it's time for the last reason for this video. And that is number 2, where it's multiple choice. There can be more than one answer. Let's take a peek at it real quick. Okay. Which of the following quotients has the same value as 5 4/100ths divided by 7? Which we just figured out, but that's okay. Be prepared to explain how you know. I'm going to challenge you to do this with little calculation, because this is the whole reason why I want to go over this pattern with you. Because if you don't recognize it or remember it, or maybe you just need a refresher, it will help with the purple book and it will help with your percents. Okay? What you'll notice with your answer choices, A, B, C, and D, they have the same digits, but the decimal is in a different spot. That's not a coincidence. They really want you to think about your number sense here. Now let's take a look at this. What if, we're going to do an exploration, and for this I want you to have your calculator the whole time. I want you to multiply these as I'm writing them down. And I'm going to record what you get. We're going to start with something simple like 6 times 10, 60 times 10, 600 times 10. And this is going to be really important. I need you to make a mental note of where the decimal is in the whole numbers. If this were money, it would be $6, $60. Oh, that's supposed to be a 600, guys. I'm sorry. And the decimal is right there, $600. And we're going to take each of them and multiply them by 10, and hopefully you did that already. Maybe you even see a pattern. Okay? You might say automatically, oh, there's a 0 at the end, but that's not what I want you to focus on. I want you to focus on what happened to the decimal point. This is $60. If I have 10 sets of $6, like all in front of me, 6, 6, 6, 6, 6, all those, like 10 times 6, right? I'm going to have $60. That decimal is right there. How about with the 600? Decimal is right here, isn't it? And then how about with the 6,000? Okay, so what's happening to the decimal point? It started here after the 6, but it's not after the 6 anymore. It moved over. This decimal point is after the 0 and 60, but it's not here anymore. It moved over. Same thing here. Decimal point is after the 600, but it's not here anymore. It moved over. That's a pattern. Every single time, it's moving over to the right one time if you've multiplied by 10. Well, what about the flip of it? What if instead of multiplying, what if I wanted to divide? How about 6 divided by 10? What about 6 divided by 100? 60. Remember where the decimal is. and 600 divided by 100. Okay. Okay, I hope you have your calculator out and you're ready and you're saying answers as this is going. What is 6 divided by 10? It is 6/10. 60 divided by 100. Oh my goodness. What did Miss Leggett do wrong? That's just great, Miss Leggett. That's just great. We were supposed to be dividing by 10, right? And I wrote the wrong numbers. I was thinking of another pattern. Okay. So 6 divided by 10, and you should have 6/10. Look at what happened to the decimal. It might help if I do that. Not needed, because those are placeholders, but it might help you visualize what's happening to the decimal. How about 60 divided by 10? And I had 2 there before, so I'll do that. 600 divided by 10. Okay, so let's examine what's happening to the decimal now. It used to be after the 6, but it's not here anymore. It's over there. Again, it used to be after the 60. It's not here anymore. It's over there. After the 600, it's not there anymore. It's over here. So what's happening? It's moving to the left one time every single time. This is not a coincidence. If you multiply by 10, it affects the decimal by moving the place value, by moving 1 to the right. And the same if you divide by 10. It still affects the place value by 1 place value. Okay, last part of the video. We're going to do the same thing, but we're going to do it with 100. And I'm wondering if you can anticipate what's going to happen. You might already know. Right? Because this is kind of like a review. I said we would do it by 100 now, right? Okay. Hopefully I don't make a typo again. Okay. And I hope you have your calculator still out because I'm going to need you again. 6 times 100. $60 times 100. And 600 times 100. I chose to put the zeros after as if it was money, because that's how we would write money, 2 places after the decimal. Let's take a look at what happened to it. It's here after the 6, but what happened? 1, 2. After the 60, but now 1, 2. Right over here. After the 600, but now 1, 2. So see that? 2 place values to the right every single time you multiply by 100. Again, not a coincidence. Let's take a look at the vision. What do you think is going to happen? Think about what happened with the 10s, multiplying by 10 versus dividing by 10. And now think about what happened when we multiplied by 100, because we're going to divide by 100 now. If you take the number 6 and you divide by 100, okay, where was the decimal before? It was after the 6, and now it's over here. Okay, let's see if it keeps happening. 60 divided by 100. It was over here after the 60. Not here anymore. Now it's over there. That's 2 to the left again. Okay, last one. 600 divided by 6. Oh my goodness. 600 divided by 100. I don't know why I do that sometimes. I say the answer instead of reading the problem. It's like my brain is faster than my vocal cords, I guess. I don't know. Let's check it out. The decimal was after the 600. It's not here anymore. It went 2 to the left. Okay? So these are patterns that you can depend on. They don't change on you. If you multiply by 100, the place value will move 2 places to the right. If you divide by 100, it will move 2 places to the left. And you might be saying to yourself, well, Miss Leggett, how's that going to help me with number 2? Because they play around with a decimal on you. If you could identify where the decimal is, you might not need to calculate anything. You might just have to study your answer choices and give it a try. And we'll see if you're right. If not, then you can do the long division or the partial quotient division that we went over today. I didn't do the long division, but if you guys need that, then I'll do that separately. Okay? All right, guys.